Hello everyone, I am Dr. Rajesh and I welcome you in this video lecture. In this video lecture we will study nth order derivative of some more elementary functions. In the last lectures we studied the successive differentiation of some of the elementary functions. So now we will take that lecture to new dimension and we'll study some other elementary functions and we will try to differentiate them n times and we will study their successive differentiation. So the first function that we will take is y is equal to log ax plus b, where a and b are constants. Okay, find yn, means their nth order derivative. N stands for nth order derivative. So now look over here, differentiating both sides with respect to x. What will get? Its differentiation will be log ax plus b will come down into the denominator. Now log is has been differentiated. Now we will differentiate ax plus b. What will be its differentiation? You know, it will be a differentiation of constant is 0 and x is 1. So this will be the differentiation. Now differentiating one more time with respect to x on both sides. We will try to generalize, and for generalization we need 3 to 4 step. So for that we will be differentiating it 2 or 3 times. So what it will be? Constant will not be differentiated. This 1 by x plus b will be differentiated. It will be minus 1 and it will be ax plus b square, and now differentiation of ax plus b, it will be a is already there, so it will be a square. Now differentiating one more time with respect to x, we will get minus 1 minus 2 divided by ax plus b raised to the power 3. Fine. This is and into a cube. So one more time, if you want to differentiate both sides, what it will be? It will become minus 1 minus 2, it will be minus 3 divided by ax plus b raised to the power 4 into a4. Now we will try to write it into symmetrical form. Like this can be written as minus 1 raised to the power 1 ax plus b raised to the power 2 into a square. Fine. And this minus 1 I am going to collect them, minus 1 raised to the power 2. Fine. 1 into 2 1 dot 2 divided by ax plus b raised to the power 3. Fine. Into a cube. This is further equal to minus 1 raised to the power 3. This will be minus 1 minus 1 minus 1, means minus 1 raised to the power 3. Now we are left with 1, 2 and 3. So this will be 1 dot 2 dot 3 divided by ax plus b raised to the power 4. Fine. Into a4. Now this can be further written as minus 1 square. 1 into 2 is 2 factorial divided by ax plus b cube into a cube. This will be further equal to minus, this can be written as minus 1 cube into 3 factorial divided by ax plus b raised to the power 4 into a4. So this thing is equal to that one. Now we will try to generalize. When here is 4, you will see here is 4, ax plus b raised to the power 4. When here is 4, here is a raised to the power 4. Here is 3, here is 3, here is 3, a raised to the power 3. So when here will be n, So now I am going to generalize and going to write yn divided by, it will be ax plus b raised to the power n into a raised to the power n. When now look over here, when here is 4, here is 1 less, 3 factorial. When here is 3, here is 1 less, means 2 factorial. When here is 2, here is 1 less, means 1 factorial. When here is 1, here is 1 less, that is 0 factorial. So whenever here will be n, so here will be 1 less factorial, means n minus 1 factorial. Fine. Now see, when here is 4, minus 1 raised to the power 3, 1 less than 4. When 3 minus 1 raised to the power 2, 1 less than 3. So when here is 2, minus 1 raised to the power 1. Similarly, when here will be n, so it will be n minus 1. So this is the nth order derivative of log ax plus b, where a and b are constant. So in the examination or when you will be attempting exercise question, you don't need to remember it. Every time you will just draw a line, and in your answer sheet you will draw a line, corner line, something like that, and you will just do this calculation here and will arrive at the nth order derivative and quickly use it into the question. So no need to remember it or memorize this result. You just have to generalize after differentiating 2 or 3 times. It's very simple. So whenever we will be doing the question, we will be again and again generalize that only whenever it will be required. We will not be doing it and we will not be remembering it. We will be doing it every time it will be required. So that was the successive differentiation of y is equal to log ax plus b. Now we will do a successive differentiation of one more elementary function, and it is given by, so next function is y is equal to a raised to the power mx, where a is constant, m is constant. So we have to find nth order derivative. Look over here. We will differentiate it 2 or 3 times, then we will see what its generalization will become. Firstly, differentiating, it will be a raised to the power mx as such into log of constant to the base e, because we know that differentiation of a raised to the power x, where a is constant, is nothing but equal to a raised to the power x as such, and differentiation of constant to the base e. So we have written it over here. Now differentiating one more, and along with it, now this is differentiated. So now we will differentiate mx. What it will be? Into m. So I am going to write it over here. This will be into m also. Fine. So now next differentiating again with respect to x, what will get? Y2 a raised to the power mx as such into log a e. Now a is, we will differentiate mx only, its differentiation is m, and 1 is already present. So this will be into m, and this thing is already there, log into m. So this is nothing but equal to a raised to the power mx m square log a square. Now differentiating one more time, differentiation of this one will be again same, and it will be log a e into m. This will be m square log a square. This is further equal to a raised to the power mx into, it will be log ea raised to the power 3, and m square will be m cube. So now we'll generalize it. We'll also write it in the same form, because here m square is in middle and here is in the end. So I am going to write it as log square into m square. Now we will generalize and we'll see that these three dots are that after generalization what will get, you will get yn, when here is 3 log a to the base e raised to the power 3, when here is 3 m raised to the power 3 and a raised to the power mx is as such. So a raised to the power mx will be as such, because when 2 a raised to the power mx is there, 1 a raised to the power mx is there. When here is 1 log a raised to the power 1 m raised to the power 1, 2 log a to the base e square m square, cube, cube and cube. So whenever here will be n, so what it will be? It will be log a to the base e raised to the power n into m raised to the power n. Fine. So this will be nth order derivative of the elementary function y is equal to a raised to the power mx. So that we will be using in the questions, and I am again saying you don't need to remember it. Whenever we will need that, we will be deriving it by putting a line to the right of the answer sheet, and we'll make some rough workspace and we'll do it over there, so that the examination could also get an idea that student knows how to generalize that result, and he has not memorized the concept, he has understand. So that will also put an impact in the mind of the evaluator, whoever will evaluate your answer sheet. Okay, so that is the nth order differentiation of y is equal to a raised to the power mx. Now we'll take the next elementary function, and the function is given by, so this is y is equal to sine ax plus b, where a and b are constants. So it will be and we have to determine nth order derivative, means its successive differentiation. How will we determine? You see, differentiating it firstly with respect to x on both sides, it will be cos, sine differentiation is cos ax plus b, and now differentiation of ax plus b will be a. But since we have to generalize, you have to pay attention that we have to generalize. So all the differentiation should be present in the sine term, so that we are in a position to generalize. So here, but it is in cos term. So what we will do? We will convert it into sine term. We will know that it is sine ax plus b plus pi by 2. If we assume it as theta, so we know that sine pi by 2 plus theta is nothing but equal to, sine in second quadrant is positive and here is pi by 2, so it will be cos theta. So it will back be same. So I have converted it into sine with this form on. Okay. Now we will differentiate again with respect to x. This we will differentiate this thing because it has come into sine now. So it will not move randomly that we will differentiate this one. No, we will differentiate this now. This differentiating both sides with respect to x will get a is as such. Sine differentiation will be cos ax plus b plus pi by 2 into a. Fine, and a into a will be a square, and once again I will convert it into sine so that we could generalize. Plus pi by 2 plus pi by 2 is nothing but equal to a square sine ax plus b plus twice of pi by 2. Fine. So this will be the second differentiation. Now we will differentiate one more time y3. Differentiate this one. It will be a square. Sine differentiation is cos ax plus b plus 2 times pi by 2 into it will be, and differentiation of ax plus b plus 2 times is both are constant, this will be 0 and ax will be a. So this will be a cube, because a square into a will be a cube. This will be cos ax, and now convert this cos into sine. Okay, convert this cos into sine and write it as sine ax plus b plus 2 pi by 2 as such. This will be assumed as theta and plus pi by 2. Now this is 2 pi by 2, this is 1 pi by 2. So 2 plus 1 is 3. So this can be written as a cube sine ax plus b plus 3 pi by 2. Fine. Now we'll try to generalize. These 3 dots shows that we are trying to generalize this thing. Put below only 3 dots. Fine. And after that we will write the generalization yn is equal to, when here is 3, a raised to the power 3, when here is 2, a raised to the power 2, when here is 1, a raised to the power 1, when here is n, it is a raised to the power n, and sine ax plus b. Okay, fine, it is as such. Now when here is 3, it is 3 into pi by 2. When here is 2, it is 2 into pi by 2. When here is 1, it is 1 dot pi by 2. So when here is 0, because this is 0 order, it is 0 dot pi by 2 is 0. So this will be, when here will be n, so it is n pi by 2, and this is the nth order differentiation of y is equal to sine ax plus b. So this will be nth order differentiation. So what we have done in the nth order differentiation, this will be, you will remember, coefficient of x will be raised n times, and this argument will remain as such, ax plus b, and along with it we have added n dot pi by 2. So this will be nth order derivative y is equal to ax plus b. That you can easily memorize, that x coefficient is raised n times, a raised to the power n, sine ax plus b as such, plus n into pi by 2. So now we will study one more successive differentiation of elementary function, and the elementary function is given by, this is the next elementary function. So now differentiating it both side with respect to x, what will get? y1 is equal to minus sine ax plus b into a. Now we have to take it into cos, because after in generalization we need cos in every derivative. So here is sine, so we know that a will be here, we know that it can be written as ax plus b plus pi by 2. And now you will ask, where is minus? Because cos in the second quadrant is negative, so whenever we will evaluate this one, this will come out to be minus sine ax plus b. So minus has been absorbed in this formula, and we know the formula is, it will be cos theta plus pi by 2 is nothing but minus sine theta. Now differentiate this thing both sides with respect to x. It will be y2 is equal to a, and a will be, this will be minus sine ax plus b plus pi by 2 into a. This is equal to a square, it will be cos ax plus b plus pi by 2 plus pi by 2. So this will be a square cos ax plus b plus 2 times pi by 2. So we have written 2 times pi by 2 because we know that pi by 2 plus pi by 2 is pi but because in the end we have to generalize, so I am written it as 2 times pi by 2. Instead of pi, I have written it as 2 times pi by 2. Now differentiating one more time with respect to x, what will get? A square minus sine ax plus b plus 2 times pi by 2 into a. So this will be a square into a will be a cube, and minus sign can be written as cos ax plus b plus 2 times pi by 2 plus pi by 2. This is equal to a cube cos ax plus b plus 3 pi by 2. Fine. Now you see, when here is 3, here is 3, here is 2, here is 2, here is 1, here is 1, here is 1, a raised to the power 1, when here is 2, a raised to the power 2, when here is 3, a raised to the power 3. So whenever here will be n, here will be a raised to the power n cos ax plus b plus n times pi by 2. So this is the nth order derivative of y is equal to cos ax plus b, and in this how we will commit it to memory. Coefficient of x is raised n times cos ax plus b as such plus n times pi by 2. So in the similar case of sine, we have written instead of cos it was a sine only, otherwise the formula will remain the same. So these are the 4 elementary functions that we have studied in this lecture, and all the 4 elementary functions are important so as to do the questions based upon the successive differentiation. So I hope that you will be able to understand the differentiation of these 4 elementary functions. So in the next video lecture, I will be taking 2 more important elementary functions that we will be requiring while we will be differentiating any given function composed of these elementary functions, and we have to differentiate it n times. We will be making use of these these elementary nth order differentiation. Okay, so that's all I have from this lecture, and if you have liked the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying you take care, bye bye, and see you soon. Thank you very much. Thanks for watching.